If you're aiming to work in data science, here are 5 projects that'll genuinely prepare you for the job market in 2026. And no, I'm not talking about the Titanic survival model. I'm not talking about the iris dataset, and I'm definitely not talking about the MNIST digit classification. Look, those projects, they taught you syntax, but they don't teach you how data science actually works inside companies today. I have been in the field for over 10 years and I've reviewed hundreds of portfolios. I've hired data scientists and I can tell you that the projects that land job in 2026 look nothing like the tutorials that we've seen before. What hiring managers want now is end-to-end business-aligned projects. Projects that show you that you understand the problem, the data, the trade-off, and the impact. These are the kinds of projects real data scientists work on every single day. And today, I'm going to walk you over 5 of them. I'm going to give you specific examples, data sets, and resources that you can use to start building them right now. If you don't know me, I'm Aishwarya Srinivasan. I have over 10 years of experience in machine learning and AI. I have a master's in data science from Columbia University and I've worked at Microsoft, Google, and IBM. Today, I lead AI developer relations at Fireworks AI, one of the top AI startups in the space. So I'll show you how data science works inside both big tech and fast-moving startups. And I know what actually gets people hired. Now, stay until the end because I'm going to be sharing some free resources for every single project that I mentioned. So let's get started. Okay, before I dive into the 5 projects, let me explain why the classic beginner projects don't cut it anymore. Projects like Titanic survival prediction, iris classification, or MNIST digit recognition, these were great learning exercise 10 years ago. They teach you how to load data, train a model, and check accuracy. But here is the problem. They do not teach you how data science actually works inside companies. In a real job, nobody is handing you a clean CSV file and saying predict this column. Real data science involves understanding business problems first. It involves dealing with messy, incomplete, sometimes conflicting data. You're making trade-offs between accuracy, speed, and interpretability. You're explaining your results to people who don't know what a random forest is, and you're actually deploying something that creates value. So what hiring managers want in 2026 are end-to-end business-aligned solutions. Projects that show that you understand the problem, the data, and the trade-offs. So let's talk about what these projects actually look like. Alright, project number 1, and honestly this might be the single most valuable project that you'll do, a customer segmentation and retention analysis. Here is why it matters. Every subscription business on this planet cares about 3 things: churn, lifetime value, and user behavior. Streaming platforms like Netflix or Spotify, SaaS tools like Slack or Notion, and e-commerce companies like Amazon or Shopify, or even ride-sharing applications like Uber and Lyft, all of them. If you can demonstrate that you can understand how to analyze customer behavior, segment users intelligently, and predict who's about to leave, you become incredibly valuable. So here is how you approach this project. First, you get a real dataset. Kaggle has several great options. So look for some telecom churn datasets or online retail datasets which have actual transaction data. You can also find streaming service data or mobility datasets if you dig around. Second, segment your users based on behavior. Think about RFM analysis. That's recency, frequency, and monetary value. When did they last engage? How often do they come back? How much do they spend? You can also look at engagement patterns, feature usage, or session length depending on your dataset. Third, and this is where most people stop, but you shouldn't, you should go further. Build a churn prediction model. Estimate customer lifetime value. Identify which segments are high risk and which are high value. But here is the most important part, and I really want you to hear this. The interpretation matters more than just the model. Anyone can train a logistic regression or XGBoost model. So ask yourself, who should get retention offers? Who should get early access to new features? Who is likely to churn no matter what you do? So maybe you just don't waste your resources on them. This project shows you feature engineering, modeling, and business reasoning all together. Companies like Spotify, Shopify, DoorDash, and Expedia hire for exactly this skill set. Now, project number 2 is demand forecasting or time series modeling. Time series forecasting is one of the most practical and evergreen data science skills. It was valuable 10 years ago, it is valuable today, and it will absolutely be valuable in 2026 and beyond. If you ask me why, because if you can forecast demand, usage, or traffic, you're immediately useful to almost any business. Retail needs to know how much inventory to stock. Energy companies need to predict consumption. And airlines need to forecast passenger demand. And tech companies need to predict server load. The applications are endless. Here is how you build this project. Start by picking a real data set. Sales data works great. So does energy consumption data, or flight demand data, or website traffic, or even weather data. The M5 forecasting competition on Kaggle has excellent Walmart sales data. There are also great energy consumption data set available on UCI and Kaggle. Once you have your data, start with exploration. And I mean real exploration. Look for trends. Look for seasonality, whether it's weekly patterns, monthly patterns, yearly patterns. Look for anomalies and try to understand why they occurred. Then build multiple models. This is key. Don't just train one model and call it done. Use a classical method like ARIMA or S-ARIMA. Use a modern baseline like Profit. That's the Meta's forecasting library, which handles seasonality really well. And if you want to go deeper, try a simple deep learning approach like LSTM. But here is what I want you to understand. The goal is not complexity. The goal is comparison and reasoning. Can you explain why one model outperforms the other? Can you articulate the trade-offs between interpretability and accuracy? Can you identify where each model fails? And finally, this is crucial, connect your forecast to business impact. Don't just say that my model achieved a MAPE of 8%. Instead, explain how better predictions reduce costs, improve staffing decisions, or prevent outages. Retail teams, supply chain teams, finance teams, transportation teams, they all love seeing this kind of thinking. Now, here is a quick tip. When presenting this project, include a section on what you would do if there were a real production system. How often would you retrain it? How would you trigger an alert? This shows that you think beyond that Jupyter notebook that you're building. Alright, now project number 3, which is a NLP-based insights from unstructured data. Now, let me be clear about something upfront. A basic sentiment analysis project where you do positive, negative, neutral classification, that's not impressive anymore in 2026. Everyone has done that. Every tutorial teaches that. What companies actually care about is extracting real insight from unstructured data. So think about all the data that exists inside of the companies, whether it is product reviews, whether it is customer support tickets, or clinical notes in healthcare. Or it could be earnings call transcripts in finance, or internal documents, or Slack messages, or emails. There's gold buried in all of that text. But most of it goes unanalyzed because it's messy and hard to work with. So if you can build a system that makes that data useful, you instantly become very valuable. Here is how I would approach this. First, pick an interesting data source. Amazon product reviews are publicly available. The Yelp open data set is also great. SEC earnings call transcripts are also publicly available if you want a finance angle. Then Hugging Face has tons of data set which you can also use in this case. Second, build a system that does something genuinely useful. So here are some ideas that you can use. Retrieval and summarization. Given a large corpus, can you find relevant documents and summarize key themes? Or you could do topic classification. Can you automatically categorize support tickets and feedbacks into actionable categories? Or you could try clustering recurring issues. Can you identify patterns in complaints or requests that the business might not be aware of? I would highly recommend to use modern tools. Embeddings in this case is your friend. You can use sentence transformers or OpenAI embeddings to represent text semantically. Show that you can understand how to work with vector databases if you're doing retrieval. And here is something most people might skip. Show how you evaluate the quality. With NLP, accuracy alone does not tell the whole story. You need to think about the usefulness. Is the summary actually helpful? Are the clusters being meaningful to humans? Can somebody take action based on your system's output? And finally, explain how a team would actually use this system in practice. Does it fit into a dashboard? Does it power to a Slack bot? Does it feed into a product decision? This shows that you understand modern NLP in real business context. It aligns directly with roles like companies at Snowflake, ServiceNow, Slack, and most enterprise AI teams. Now, project number 4. And honestly, this is a massive differentiator. Experimentation and Uplift modeling. Here is something that might surprise you. Most tech companies don't ship features based on someone's gut feeling. They ship based on experiments, which is A/B tests. or controlled rollouts. At companies like Meta, Airbnb, Netflix, or Uber, experimentation isn't just something that data scientists do occasionally. It is a core part of the product development process. Thousands of experiments run simultaneously, and yet most data science portfolios don't include a single experimentation project, which means if you have one, you immediately stand out. So here is how I would build this. First, find a dataset with treatment and control groups. Kaggle obviously has a lot of A/B testing datasets. There's also some great causal ML datasets available. If you can't find one, you can also simulate a realistic experiment. Just be transparent about it. Second, run a proper A/B test analysis. Calculate your metrics correctly, check your statistical assumptions, and understand significance versus practical significance. Now, here is where you really set yourself apart. Go deeper. Try estimating the uplift. Don't just ask, did the treatment work overall? Ask which users benefited the most. That's called uplift modeling or heterogeneous treatment effect estimation. And it is a huge win for personalization. Do a power analysis. And before you started, how many users did you think you needed? After the experiment, did you actually have enough data to be confident in the result? You need to segment your results. Does your treatment perform better for new folks versus loyal customers? Mobile users versus desktop users? And finally, crucial step that so many people skip is make a clear decision. Based on your analysis, would you ship the feature or not? Would you roll it to everyone or just certain segments? Would you run the experiment longer to get more confidence or just shut it right there? Being able to make and justify a recommendation, that's what most companies are looking for. I highly recommend reading the engineering blogs from Netflix and Uber on experimentation. They are free to read. They are super detailed and they'll give you a sense of how seriously these companies take this discipline. Alright, now we are at project number 5, and this is one that turns you from a learner to somebody who's actually hireable. An end to end ML system with deployment. Here is the reality of data science in 2026. You are expected to understand the full life cycle of a model, not just training. Not just evaluation, but deployment, monitoring, and maintenance, which is CI, CD, CM, CD. A model that lives in a Jupyter notebook creates zero business value. A model that's deployed and serving predictions and being monitored, that's what's actually useful. So here is how I would actually approach it. Start with a practical problem, something that's real. Say predict ride cancellations or detect potential fraud signals or build a recommendation or ranking system. Or it could be something like classify images for an actual use case. Just build that model, but while you're building it, track your experiments. You can use ML flow or weights and biases or even just a well-organized spreadsheet to do that. Show that you care about the reproducibility and iteration. Evaluate with sensible metrics, and I mean metrics that a business person would understand. Not just things like F1 score, but talk about precision and recall in terms of what they mean for the business. What's the cost of the false negatives versus the false positives? Then deploy it. I know this sounds intimidating, but it's easier than you think in 2026. You have so many different options. Streamlit is there for quick data applications, Gradio for machine learning demos, and Fast API for building small prediction APIs. Just pick one and just do it. A deployed model, even a simple one, is worth 10 times more than a fancy notebook that only runs on your laptop. And finally, most importantly, add monitoring, or at least a clear plan of how you would do it. How would you detect if the model performance degrades? How would you handle data drift? When would you retrain it? You don't have to build a full MLOps pipeline, but showing that you have thought about these issues signal that you're ready for a real job, not just a course certificate. So there you have it. 5 projects that'll genuinely prepare you for the data science job market in 2026. Now, I've put all the 3 resources that I spoke about in the description below. The datasets, the learning platforms, the deployment tools, everything. Make sure that you check all of them out. I've also organized them based on the project, so you can jump straight to whichever one resonates the most with you. And if you found this video helpful, hit that subscribe button and turn on the bell icon so you don't miss my new videos. I regularly post AI and my career tips, free resources, deep dive educational explainers, and I also share my personal journey navigating my life in the US as an immigrant while building a career as an AI leader. Alright, now go build something amazing and I'll see you in the next one.